Before we start our rig, we're going to define our Houdini digital asset. And the easiest way to do that is to just start with a subnet. And I'm going to give this a name and right-click, Create Digital Asset. This dialog will allow us to create the name, the label, and tell Houdini where to save this library to. In this case, I'm going to use soldier, and then I'm going to use 2 colons and say 1.0. This will allow me to version my asset. So if geometry changes or some functionality changes, I can increment this and keep track of different versions. For the label, this can be anything you want. It's not really important to match these two, but in this case, I am going to take off the version. And then the library is going to be saved to my desktop. I'm just using my desktop for the purpose of this tutorial. You'll want to save this somewhere a little safer. But for now, I'm just going to say soldier. And inside this soldier directory, I'm going to create a directory called HDA. And then here, soldier.hda. And then I hit accept, and I'll get this edit operator type properties dialog. And this is where we'll be able to define all of our parameters. We'll be able to add some code. We'll be able to add extra files. And then on this basic tab, we can see that our label is soldier, and we can change this at any time. We can see that we are saving the library here to the desktop soldier HDA. And then importantly, minimum inputs and maximum inputs. Minimum inputs should be 0. We don't ever want to force the user to have to put something into our soldier. But maximum inputs, I'm going to put it to 1 and hit apply and accept. And that will give us this input here. So if we ever have a transform that we need to send to override where our soldier is, let's say we've attached this soldier to a vehicle or something, you can use this input here. And we can go inside and we can see that this is the node that represents that incoming input. Up on our parameter panes, we can see that we have a transform and we have a subnet. But we don't want to transform our HDA. I think of HDAs as being a world, and we want our world for the HDA to match our world of our scene. So we're going to lock all of these, and this will prevent accidental scaling or transformation. And then back in our operator type properties, we're going to select the transform and make it invisible, and the subnet, make it invisible, and then hit accept. And that will clear these out. They're still there. If we show invisible parameters, we can see them and we can modify them if we need to. But we can just get rid of them for our user. Now that we've created our HDA, let's dive inside and attach to this incoming transform just a null. And we're going to call this null hidden transform. I'm going to turn off its selectability and its visibility. And the reason I add this is that even though our user, our animator, is never going to use this transform, having a transform above any of the actual rig transforms allows, in some extreme cases, maybe a layout artist or an animator or someone to go in and not touch any of the actual animation, but to move our character. So let's say that a character has been set up in relationship to an environment or to other characters and a camera, and the whole thing needs to be moved around somewhere for some reason. This will allow that movement without affecting any of our animation. So before we start rigging our character, it might be a good idea to bring in our geometry so we know what we're doing. So I'm going to bring in our soldier. So he's got a geometry node. I'm going to turn off the selectability of this. And inside is just a file SOP pointing to a location on disk. And to start with, I'm going to use a null, wire it straight into the hidden transform. I'm going to call this master. And I want the control type to be circles and on the XZ plane. And then in order to make this larger, I'm not going to use the scale on the Transform tab. I'm going to use the Display Scale. And I'm just going to put that at, let's say, 2.5. We're going to try our best throughout this tutorial to promote parameters as we go along rather than having to do a whole bunch at once. So I'm going to promote on this master control the translate, the rotate, and the uniform scale. And I can do that just by right-clicking here in this path and say type properties. And I'm going to bring a folder in from the create parameter area. I'm going to name this folder master. And then just drag and drop the translate, the rotate, and the uniform scale. You'll notice that they have a T2 here, so translate to. That's because there is already an existing T parameter from our original OTL or HDA transform. So I'm going to rename these. And hit apply and accept. And now you can see that on the master null, the translate, rotate, uniform scale have been promoted. And if we go to parameters, we can see that we have these promoted, and we can scale and use those parameters. I'm also going to lock the scale, pivot translate, and pivot rotate parameters. Parameters that we don't use, it's a really good idea to lock them off just to prevent any accidental transformations. Much later on in this tutorial, I'll be writing a script that will allow us to select a node and just click a button, and that will go through and find any parameter that doesn't have a promotion link here. It'll just lock them off automatically. Now we can start building our spine. In order to do that, we're going to come into the side view and draw the spine here through the torso. But my arm is in the way, so I'm going to go into the soldier body, and I'm going to use a clip sop. And I'm going to set that to X and below the plane. I can use this to just clip out that arm, which when we go back into the side view will allow us to see our spine, our torso without any distraction. So to build our spine, we're going to use the Bones tool. And it's important to look up here in the toolbar for our Bones tool. Here we can set the chain name. This is the prefix for each of the bones that we're going to create. We can decide on a kinematics while we're building the bone chain. But then placement is pretty important. Right now it's on view-based. And what that will do is it will detect the geometry underneath our cursor and fire a ray from that piece of geometry through to the next piece of geometry. So it'll find this thigh, for example, and it'll put the bone right in the middle. But in our case, we want the spine right through the center line. So we're going to change that from view-based to freehand. And then up here where it says chain name, we're going to say spine. And then we have no kinematics. I'm going to start my spine, I think right about here. And if I click once and drag out, we have one bone. But you'll notice that now that I've activated the tool, this divisions parameter up here has been activated. And right now it's set to 1. So that means there'll be one bone created. But if I use my scroll wheel, you'll notice that I can change the number of bones. And you'll see that the number of bones in the viewport changes, but also this divisions change. So I'm going to set this down to 6. And then go pretty straight, right about there I think will be all right. And just click once. And now if I click off, you can see that I can create another 6 bones. Or I can just right-click and say Finish Drawing. And now you'll see in our viewport, we have a spine root, which is a null at the base of our bone chain. And then we have spine underscore bone 1 through bone 6. I'm going to rename our spine root to be just spine root. Take off the 1. And then while I'm still in the Bones tool, I'm going to change that to pelvis. And we're going to build a pelvis bone just sort of back and down a little bit. So you'll notice that in the Bones tool that each of our bones have a little square blue thing. And if I head over here and mouse over, now you'll see that I now have an XYZ prompt in my cursor. And what that enables us to do is we can now select one of these bones like that. And now I can move it around in the bones tool. So this is repositioning the built bones that I have like that. But I don't want to do that. I want to draw right from here down to the pelvis. But how can I do that when if I click here, it's going to select that bone? Well, the way to do that is to use the B key. And that will temporarily hide these little blue selecting things. So I can use the B key and just select there. And you can see that it remembered that I wanted 6 divisions, but I can just scroll that down to 1, and I'm going to put the pelvis bone about there. Now you can see I have a new chain with a new root. And in this case, I'm going to take this one off and this one off. And now that we've finished with our spine, we can hit Escape to get out of the Bones tool. Now what we want to do is create an IK control. And how we're going to do that is using the Path tool. So in the viewport, type Path, Create. And the path we want to create has 3 control vertices. One at the root, one at the center of our spine, and one at the tip of our spine. So here, here, and here. And then we can right-click and finish drawing. And now in our network, you can see that we have 4 new objects. We have a path object, and we have 3 path CV objects. I'm going to rename these to spine path. I'm going to rename this first one down here to be spine hip CV, this middle one to spine mid CV, and this last one to spine chest CV. It's worth taking a moment to examine what these things are and how this spine path is being built. So to do that, I'm going to hide my bones and geometry. And if we turn on points, we can see that each of these spine CVs is actually just a null that's been scaled non-uniformly. And how the path is being built, you can see if I rotate this, you can see I have a kind of a Bezier path being built here. If we go into the spine path, we can see that at the very top, all that's happening is that we're merging in the points of those CVs. So these points are being brought in for each of these nulls. And then if you look at here, the top and the very, very bottom, we're deleting those 2 top and bottom points, leaving just these. And then these are connected with an add SOP. We turn off. And then that is being converted into a Bezier curve. And so when we rotate one of these, the point at this bottom CV that's being retained is being used kind of as a tangent handle. And that's controlled by this scale parameter here. So we can make a very broad or very narrow curve. And what we're going to do is actually delete a couple more of these points, because we're going to convert this not into a Bezier curve, but into a NURBS curve. So I'm going to use a delete. And in this delete set to points, I'm going to delete 0.2 and 0.4. And what that will leave us with is a NURBS curve that can be controlled from this CV rotationally as well as transformationally, and this one at the hip, which will be able to rotate and change the shape of the curve. This mid one will only be able to translate around. So rotating this one won't have any effect because we'll be removing these 2 points. And those 2 points are 0.2 and 4. And now we connect that back in, change this from Bezier to NURBS. Make sure that display is on. Whoops. Go back up, turn off points. I can hide these for a minute. So now if I rotate, you can see that that's the IK control that we're going to have on our spine. If I move this guy, rotation doesn't have any effect, but translation will. So we can move the middle of our spine around with that control. I'll turn these back on. We're going to be using this path to drive our spine. So we want to make sure that these path CVs are in exactly the right spot. So to do that, it's simple enough to show our bones again. I'm going to take all of these path CVs. I'm going to turn on keep position when parenting. And then just parent them to the positions I want them to be in and extract their pre-transforms. So in the case of this hip CV, I want it to be right at the root of the spine. So you can see that it's off by just a tiny amount. So I can set those to 0. And then this rotate X should be 90 degrees. So let's take that off. For the mid CV, should be right there at the root of bone 4. So again, extract that pre-transform. Tiny little amounts in translate and in rotate. So now it's exactly where that bone rests. And then for the chest CV, I want it to be at the tip of this last bone. So when I extract this transform, I'm going to remove the rotate, remove the translate in X, but this translate in Z I want to keep because I don't want this to be positioned at the root of the bone. I want it to be positioned at the tip of the bone. So how do I get that value? Well, I can go to the bone, to its bone tab, and there I can get the bone length. So I'm going to copy that amount and paste negative that amount into the path CV, and that will place it exactly at the tip of this bone. And then we're going to remove all of these connections. You can just hold Y and cut. So now each of these is free to be placed into our control hierarchy, but they'll be at the correct positions for our bone hierarchy. Now we can start building the IK controls for our rig. So I'm going to start with 3 nulls, and I'm going to call the first one hip IK, second one mid IK, and the third one chest IK. And just like we did with our path CVs, we want these to be just in the right spot. So with the hip IK, I'm going to parent it to the spine root, so it ends up right there. Then I'm going to turn on keep position when parenting, and now cut that link. For mid IK, going to go to the root of spine bone 4, so it's right there. Keep position when parenting, cut that link. For chest IK, I'm going to go to the root of spine bone 6, and then I'm going to, again, find that bone length. I'm going to copy that value, place the negative of that into the translate Z, then keep position when parenting, and cut that link. And now these 3 are in exactly the right spot to drive the spine CVs, which will drive our spine path, which will eventually drive our spine. So while the position of our IK controls are in the right spot, their orientation isn't what we want. If we look at the chest IK, we can see that it's pointing down in Z and forward in Y. And what we want is for these to be oriented in the world space. So the easiest way to do that is to grab all of our IK, extract the pre-transform, and we know that the translates are correct to place them in these positions. But the rotate, we just want to ensure that that's 0. And you can see that now the chest, Z is facing outward, Y is up, mid, Y is up, hip, Y is up. And then we're also going to change the display of these IK controls. So on the miscellaneous tab, we're going to change it from a null to, let's say, a box. And we can make that box much more narrow and a little bit smaller. And it would help if we turned on our body to give us a better indication. So that looks pretty good for our hip. For our mid, go down to box, scale that down. Whoops. Maybe a little smaller. Scale that down a little bit. And then for our chest, again, box, scale that down, scale it overall just to approximately where our shoulders are. That should be pretty good. Now that we've done that, let's turn off our body again. And let's also turn off the display of our spine CVs. And let's parent them to the controls that we want to control them with. So spine CV, key position when parenting, make it a child of the hip. Mid CV, its key position when parenting is on, make it a child of mid. And then the chest will be the parent of the chest. And then this spine path, we want to make this the child of the root, so that as our root moves through the world, it will take this path object with it. So now that we have our IK controls set up, let's now bind our spine bones to that spine path. And to do that, we'll go back into the Bones tool, and up in the Kinematics dropdown, we'll choose Follow Curve, and then we'll right-click in an empty space in the viewport and select Add Kinematics. So that tells the Bones tool that we want to add kinematics, and the type is Follow Curve. So now, down in the prompt here, you may have it in your viewport. I have mine in the status bar down here. It says select the first bone of the bone chain and press Enter to continue. So I'll select spine bone 1, Enter to continue. Now it says select the last bone of the bone chain and press Enter to complete. So spine bone 6, Enter to complete. And now it's asking for the curve object, and that's our spine path. So I select that and hit Enter in the viewport. And now you can see a new node is turned up. Here it is here. It's a chop network called Kin Chops. You can leave that name, it's fine. And if we go inside, we can see that we have an inverse kin chop called Kin Spine Bone 1, and it takes that name from the first bone in the follow curve. You can see that our root bone is spine bone 1, our end bone, spine bone 6. The curve object is soldier spine path. So we can go back up. And now if we hit escape to exit out of the bone tool, and we select one of our IK controls, you can see that our spine is now moving with our curve. But you can see that I can stretch the spine way out, and the bones maintain their length. To drive the length of our bones, we're going to be using an expression called arc length. And where we can test that out is if we just select one of our bones, and then here in the bone length parameter, you can enter into it and select Alt-E, and that'll bring up a little expression editor. So the expression that we're going to use, if you go to Windows HScript textport, you'll get this little sort of shell-like thing. And you can type xhelp and then the name of the expression or function that you're looking for. And if it exists, you'll get the documentation for it. And so this is the arc length function here, and it returns the arc length of a curve between two U positions. So we can use can just actually just grab this whole thing and replace the current bone length with that expression. And then we can just fill in the proper values here. So in the case of the surface node, what we want is our spine path. And helpfully it attempts to fill that in for us. So we can just look down this list for spine path. And then the primitive number is just, in this case, 0, because there is only one primitive in our path node. And then the uStart and uStop is the place along the curve that we want to start and stop. And in our case, that's 0 for the beginning of the curve and 1 for the end of the curve. We want the whole curve. So we can hit apply and accept. And now you can see that the bone is much larger than it should be. Well, that's because we need to take this value and divide it by the number of bones that we have, because this length is the entire length of the curve. So we can just say divided by 6. And now our bone is still the same length. We can test that by toggling the expression or value display, and we can compare that to another bone. So those are the same, well, almost exactly the same length. So what we can now do is we can copy this and we can paste it into all of our bones. And now the bone lengths are going to be 1/6 of that curve length. So if we take our IK control and if we stretch that curve, our bones are going to stretch. So instant squash and stretch right there. So now that we have our IK all set up, we want to add the FK control to ride over top of this. So again, we're going to create 3 nulls. And the first null we're going to call spine A FK. The second one, spine B FK. And the third one, unsurprisingly, spine C FK. And just as we did before, we want to use our existing structure to place these nulls right where they should be, because right now they're just sitting at the origin. And where we want them is to be down here at the root, and then we want one after the second bone, and then after the fourth bone. So sort of right in between our IK controls. So for the spine A control, we'll use the hip IK location, keep position when parenting, and then cut that link. Spine B, we want it to be at the root of the third bone. So we'll use the third bone, keep position when parenting. We'll cut that link. And then spine C at the root of the fifth bone. Keep position when parenting. Cut that link. And then again, we want to grab all these guys, extract their pre-transforms, so we know that their translations are correct, but their rotations, we have to force that to be 0. So now when we select them, Y is up, Y is up, Y is up. And then, just as we did with the IK controls, we're going to change the display of these guys. So we can select all 3 of them, go to the Miscellaneous tab, change the control type to circles, change all planes to ZX plane, and then we can resize these. Again, we can turn our soldier back on and size these to fit depending on our preferences. We can move these around and change them however we want later, but for now this will be fine. So now that we've built our FK controls, we can parent spine B to spine A, spine C to spine B. So now we get nice rotation. And just so that we can differentiate these a little bit, we're going to change the colors of these. So our FK, we're going to go to the miscellaneous tab, look at wireframe color, and then let's choose this sort of bright blue. And on our IK, we're going to choose a sort of a cream color, just so that we can easily identify the difference between the IK controls and the FK controls in the viewport. And now, before we hook up our FK control to our IK control, I'm going to make another sort of master null type thing here. So a null parented under the master. And I'm going to call this one COG. So that stands for center of gravity. And I want to place this null somewhere in the middle. It's really up to you. Belly button is usually a good place. This guy's got kind of a low belly button. So I'm going to put it just here in between these two FK controls. And I'm going to change its color to something fairly prominent, like, yeah, red is fine. Then we want circles on the ZX plane. I'm going to make it kind of large. So that's the center of gravity for our whole character. So selecting and moving this around is going to move the whole torso, but it won't move the IK on our feet and wrists. So it goes right below the master. Now we're ready to assemble our rig. I'm going to start with the center of gravity, and I'm going to clean its transform. The center of gravity is going to be the parent of the spine A FK, and the spine A FK is going to be the parent of the hip IK. The hip IK is going to be a parent of the spine root and the pelvis root. The spine B FK is going to be a parent of the mid IK. The spine C FK is going to be a parent of the chest IK. And now we can test to see if any of this is broken. I'm going to start with our center of gravity, and this control is going to be able to translate and rotate. So if we rotate it, you can see that all of our controls for the spine and torso are coming along with it. We can translate it as well. Our hip IK is just going to be a translation and also rotation. We can see that it rotates, it translates. Our mid IK is just going to be translation. And there's our chest, can translate and rotate. And then our FK rotates. So that's great. So there are a couple of things that we need to finish up before we're done with our spine. One of them is to go through each of these controls and not only clean up some of the transform values that are here, but also determine which of these parameters we're going to promote to our HDA to allow our animators to access just the parameters that we want them to be using. So we're going to start with, well, the master we've already done. So now we'll do the center of gravity. And this one is going to have translation and rotation. So here on the soldier, I'm going to open the type properties. And I'm going to create a new folder. I'm going to call that spine. And then I'm going to promote from the center of gravity, I'm going to promote the translate and the rotate. And then I'm going to lock everything else. So here, I'm going to name this cog trans. Cog rote. I'll go through and do the rest of these, and then I'll come back and show you what I've done when I'm finished. All right, I've promoted all of the parameters that I want for the spine FK controls and the IK controls. And the naming conventions that I'm using here are really up to you. You can choose to do whatever you want. I like the center of gravity to just be sort of on its own, but I really do prefer all the other basic body parts, like the spine and the arms and the legs, to have a prefix of what that body part is. But you can choose not to do that if you want, just so long as that these parameters are easily identifiable. So I've gone through and I've made all of these. I'm going to hit apply and accept. And now you can see that each of the ones that I've promoted are locked. So let's go through these individually. Spine, AFK, BFK, and CFK. Everything is locked except for the rotate, and that's been promoted. For the hip IK, mid IK, and chest IK, everything is locked except for the translate and the rotate. Another thing that I like to do is in the network, you can see that from a little ways away, we can kind of identify bones easily because they have that kind of cream color and sort of darker color for the kin chop network. But our actual controls are a little hard to identify. So what I like to do is to just, in the network, take controls that actually have a channel reference on them. And that would be just these. And I like to color them in the node editor. And you can do that just by hitting C on your keyboard with your mouse in the network, and you can bring up this color palette. So I'm going to grab all of these controls, and you could differentiate between FK and IK if you wanted. I don't find it necessary personally. And I'm going to choose this sort of darkish green because it kind of matches the green of the promoted parameter. And then just hit C when you're done. Additionally, I'm going to go through and at least temporarily turn off the selectability of all the bones, because we really shouldn't be touching them at this point. If we want to move a bone, we have lots of rig stuff to move our bones. And additionally, the path selectability and visibility, the root nodes of our two chains, selectability and visibility can be turned off. And I think that that's just about it for our spine. So we have a functioning spine, but you'll notice that when we use it, we're not getting any kind of activity in this mesh. And we'll go through a method of chopping this up and creating proxy geometry so that we're not deforming the geometry, but the animator will see this geometry being animated in the viewport. And we'll do that next. Before we build our proxy geometry, there's a little thing that I forgot, and I seem to forget this every time I build a rig. And that is, we haven't made a control for our pelvis. We have a hip IK control, and if we rotate it, we can see that our pelvis bone is rotating. But we don't have an individual control just for the pelvis. And the easiest way to do that is to use this null that we have when our pelvis bone was built. We got this pelvis root. So I'm going to turn that back on. I'm going to give it a green color because it's going to be something that we can animate. And I'm going to promote its rotation. I'll call that accept. Lock all this stuff. And then for the control itself, I'm going to go inside and I'm going to paste a little network and wire it into the control SOP. And all this is a sphere and a line, and then the line or the sphere has been copied to one of the points of the line, and then those two things have been merged together. I'll show you what that looks like. So we have just a primitive sphere. Then we have a line that has 2 points. And then we're copying the sphere onto the first point of the line. And then we're going to merge those two things together. So we get a ball and a stick. And then we feed that in as the input to the control SOP. So now we just have to go up and on this null, change this control type to circles to control SOP input. And now we get this little ball on a stick, and we can use that to control our pelvis independently. And you could go inside and change the direction of this line to change the angle of that line and ball. But I kind of like it the way it is there. And you can see that when we rotate our hips, that will come along for the ride, but then we can still go in and rotate the pelvis independently if we need to. For our proxy geometry, what we're going to be doing is creating a new geometry object here at the object level and filling that with a piece of geometry from our mesh and then parenting it to each of these bones so that as we manipulate our rig, we'll be rotating a bone, and that bone will be a parent of a piece of geometry, and that will move in the viewport. And rather than have you sit there and watch me doing this, because it's kind of a tedious process, I'm going to go ahead and complete the proxy geometry for the full spine. And then I'll come back and I'll give you an overview of what I've done. It's all very simple, but as I said, it's tedious and boring to watch. So I'll come back in a minute and show you what I've done. To make the proxy geometry for the spine, I first made a geometry object for each of the bones, for the pelvis and all the spine bones. And I named them the respective bone name plus proxy and colored them purple because proxy starts with P and purple starts with P, and they're easy to identify. And then what I did is I went into the soldier body, and you can see I've turned him off now. But inside, off of the main soldier body mesh, I just made a bunch of groups. And those groups align with approximately the bones that I want to move them with. So in this case, pelvis, spine 1, spine 2, spine 3, 4, 5, and 6. And you don't have to be super precise about these. They're really just to give a general indicator for the animation department of what their rig is doing and what the final deform is going to be looking like. So you don't have to really worry about, should I put these polygons into the group or not? You don't have to spend that much time on it. After I did that, inside each of these proxy objects, I used an object merge, and I pointed it to that soldier body geometry. But then I used the group field to specify the group that I wanted. So in this case, spine 1, since I'm in spine 1 proxy. And so I get just that piece of geometry. Another way to do it would be to use deletes inside the soldier body and to delete off bits of the geometry. But I find groups are easier because they're easier to change later, and then this will just update. And then I follow those object merges with a null that I've locked. And the reason that I've locked it, if we go up and look at this pelvis, and if I unlock this, everything still works. But if I rotate the hip, the pelvis doesn't follow. The pelvis controls follow, the pelvis bone moves, but the pelvis geometry doesn't. And the reason for that is that for every instant that I am updating the rig, this object merge is recooking. And so it's moving because its parent is moving. Then it's recalculating, well, what is the soldier's body? Where is the pelvis group? Bring that into this object. And that is changing every time. So in order to prevent that, I just use Control-click on the red flag to lock this geometry. And we'll be dealing with this in a better way, a more pipeline-friendly way later on. For now, this is fine. But now that I've done that, these proxy objects, whoops, looks like that one's broken. one is that? Oh, there we go. Yeah, that's got it. So now we get a nice indication of how our spine is moving. We can see a nice twist. Next, we'll make some groups for our controls and our bones and our proxy objects, and we'll make them here in the network using node groups. And then we'll edit our parameter pane. Right now we just have the master, we have the spine, but it would be nice to be able to turn some of these things on and off in the viewport, because this can be somewhat cluttered. So we'll see how to deal with that next. At the moment, we only have a dozen or so nodes in our network, and it's pretty easy to tell what's what and to select the ones that we want. But once this network grows to hundreds of nodes, it'll become much more difficult to manage. But one thing that will help is something called node groups. And with your mouse here in the network, if you type Shift-Z, you'll get this little drop-down. And this is where we can make node groups. And I'll make a really simple one just to show you an example. I'm going to select all the spine bones and the pelvis bone, and I'm going to drag them up into here and drop it. That's created a new group, in this case called Group 1, but I'm going to rename that Spine Bones. And you can see that there's a little yellow square here, and then a blue one, and then a brighter blue one, and these have some numbers in them. So if I have nothing selected, and I use this yellow square, you can see that I'm able to select all of the bones that are in that group. And this is really handy, because let's say I'm way out here looking at some other part of my network, and I need to select my spine bones. Well, I could zoom all the way in, select them, and then zoom all the way back to where I was. But I could also just do that, and you can see that I'm selected all of my bones. And additionally, it'll tell me how many nodes are in this group. So the spine bones is 7. So I have 6 here and pelvis bone. So I'm going to create a proxy group. Call this spine proxy. And then I'm going to create a spine controls group. I'm going to include the cog, center of gravity, in that group, but I'm not going to include the master. And you can open this window larger if you need to. And so now not only can I select these things using this node group interface. Oh, and I've forgotten the pelvis again. So I'm going to select my pelvis root, and I can use this little arrow drop down, and I can say add selection to group. So now the pelvis is also in there. And as you could see, I could also use this to remove a selection from group, or I could just delete the group entirely. But another thing over here, the D just here means display. So with nothing selected, I could go to the spine controls, and I could click the darker square here. And you can see that in the viewport, they've been turned off. And then I can turn them back on again by hitting the lighter blue here. So you can see that the visibility flag has been turned on and off. So this is a quick way of as I've said, if you're way out in the network or just in another place, even if you're zoomed in, but maybe you're over here doing something and you need to turn off all of the spine controls for some reason, you can just open up the node group with Shift Z, turn them off, turn them back on again. It's very convenient. So we're going to be doing that for all of the different sections of our rig, for the arm and the hand and legs and feet and the head and the neck. Now we're going to improve the look and usability of our parameter interface. Currently, our Soldier HDA has a master tab and a spine tab. And we just have the basic transformation parameters in here. But what will be useful is to have parameters that will turn the master control on and off, that will turn the spine controls on and off, turn the bones on and off, and the proxy. So we'll add those now. In our type properties, you can see that we have our master folder and a spine folder. And then we have our three master controls. Oops, and this one is spelt wrong. Correct that. What we're going to do is we're going to add 3 folders to this master folder. And the first one we're going to call M_display and a label display. And then we're going to select it and hit D to duplicate it. And you can see that it tries to reuse the name, so it put a little 2 after M_display. And that's all right. We can probably change that later. But for this one, we're going to give it the label of controls. And then we're going to duplicate this one. And we're going to call this one actions. And right now, these 3 are in fact controls. So I can actually select those and then drag them into the controls folder. And if I hit apply and then look at my parameters, you can see that we have in our master folder, we have a display folder, a controls folder with our 3 controls, and an actions folder. Display and actions are empty right now. And that might be fine. You might be comfortable with having these little tabs. But sometimes I prefer to have them all displayed in a single column, but with little decorators to differentiate them. So the way I'm going to do that is I'm going to change the folder type on each of these from tabs to simple. Simple. And for some reason, changing the folder type has allowed me now to change these names. So I'm going to change these names to controls, M controls, and M actions. The name of the folders aren't all that important. If you're not able to change the name, don't worry about it. You're rarely going to interact with these folders by name. For our users, the label is much more important. So now if I hit apply, having changed these to simple, you can see that we've lost our display and actions, but our controls now is a little label on this kind of group field here with a little border around it. And the reason that we don't see anything display or actions is because they're actually empty. So we can fix that if we just add, say, an integer to each of them. And now we hit apply. And now you can see that this is how our controls are going to be displayed. So for the actions, I'm going to remove this one, and we'll get back to it later. And for display, I'm going to use this simple integer, but I'm going to add 3 more of them. First, I'm going to change the name of this to mDisplay. So this one is going to be called master display. Then I'm going to duplicate it, and it's going to be called GDisplay. Call this GO display. I'm going to duplicate that one. I'm going to call this B display. Bone display. And finally, C display controls display. I'm going to hit apply, and you can see that these are now integers. But I don't want to use integers. I want to use little drop downs. And what these are going to control is this one, the master display, is going to control whether or not we see this master control in our viewport. The geo display is going to drive all of the other tabs. All the other tabs are going to have a display for what type of geometry we see, whether we see the proxy geometry or the final deformed geometry or nothing at all. And so on the master tab, there'll be an overall geo display control. And then the same for bones and for controls. So that instead of going to the spine and the arm and the leg and the foot and turning all of these off and on individually, we can use the master display just to drive all those other tabs. So for each of these, I'm going to come over here to the menu tab, and I'm going to say use menu. Now I'm going to say that the menu item 0 is going to be off, and menu item 1 is going to be on. And now when I hit apply, you can see that our master display has changed from this integer to an off-on little combo box. So I'm going to do the rest and come right back. So I've finished adjusting the parameters for our other display combo boxes. So now the master display can be off and on. The geo display can be off, proxy, or deform. Bone display, off on, controls display, off and on. I'm going to take the geo display, bone display, and the controls display. I'm going to hit D to duplicate them. I'm going to drop them into the spine folder. So we're going to need these here as well. And I'm going to rename these for spine geo display. And just like in the master, I'm going to create 3 more folders. I'm going to move those to the top. I'm going to change all of their types to simple. And then, just like in the master, we have M display here. I'm going to say S display and call this display. Controls, so now we have S controls, call this controls. S actions, call this actions. And I can take these 3 display controls, put them into display. I can take all of our controls, put them into controls, and I can leave actions empty for now. We'll get back to that later. So now when I hit apply, we have master with display controls, and spine with the same display controls as master, and our controls are nicely grouped into this little region. Next up, we'll see how to use these controls to actually drive the visibility of these objects in the viewport. Before we use these parameters to drive our nodes, we'll want to have a look at the default values that they have. Currently, the geo display is set to off, but what we really want is proxy. You can see when I change this, proxy becomes bold, and so does the spine tab. That's to indicate that these have non-default values. So what I want is for that to be proxy and not off. Also, the controls display, we want to be on by default. And the way that we can do that is to, in the type properties dialog, we can come to geo display, go to the channels, set that to 1. Similarly for controls display, set that to 1. And now when I hit apply, our spine GeoDisplay default is proxy. You can see off is non-default, proxy is display, and controls display is set to on. So now I can come over here and I can select all of my proxy geometry. I can come to the Render tab. We can drive this display parameter. We can do that just by clicking and dragging and dropping that and selecting Relative Channel Reference. And while this works, if we set GeoDisplay to off, our proxy disappears. Set it to proxy, it's on. If I set it to deform, it stays on. And while it might seem like that's a good thing, it's actually not, because we don't want the proxy to be visible when our deform is visible. So if we look at the value that is being sent to each of these pieces of geometry, we can see that it's taking the value from this parameter. In this case, it's displaying 1, but deform is actually 0, 1, 2. So we need to fix that. And the way that we can do that is just with a simple expression. So let's just take the proxy first. So instead of just directly referencing this value, we can use an if statement. So we can say if, and then parentheses. So if that value equals 1, then 1, turn on. And if it doesn't, turn off. And close those parentheses. So now you can see that our proxy for our pelvis has disappeared because this GeoDisplay parameter is not 1. It's actually 2. So off, everything turns off. Proxy, everything turns on, including our pelvis. But if I turn this to deform, that disappears. So we can use this expression, copy, and we can paste it into all the other proxy objects for our spine. And now you can see they all disappear because we've set this to deform. If we set it back to proxy, everything turned back on. Off is off. So we'll continue and do the same to the bone display. We can just simply grab all our bones, go to the Render tab. In this case, we need to turn on, activate the display parameter. We can grab the bone display parameter name, drop it right in here, relative channel reference. And now bone display is off, bone display is on, so that's working just fine. And again, for the controls, grab all of our controls, go to their Render tab, turn on the display parameter, grab the controls display, drag, drop, relative reference, and now you can turn those off, turn the bones off, everything's off. Proxy, on. And there we go. We've finished our spine. Next we'll be building the rig for the neck and head. But before we do that, we're going to install a couple of shelf scripts that will help us perform a number of repetitive tasks more quickly. The first is a shelf tool that will lock the parameters that we're not exposing to the animator. And the second will be a tool that will build a set of nulls that we'll be using as control objects. To install the shelf scripts that we're including with this tutorial, come up to the plus menu here in our shelf and say New Shelf. And go to the options. And depending on the operating system you have, you should have a path similar to this. It will be Documents and then the Houdini version that you're running, Toolbar, and then the path will be Default Shelf. But we're going to change that. We're going to say Rigging Tools. And then the name of the shelf is also Rigging Tools. And then the label is Rigging Tools. We can hit Apply. And now you can see that we have a new shelf called Rigging Tools. So we want to apply and accept. And at this point, we want to save and exit Houdini. And now, go to your Documents folder. And again, depending on the operating system you're running, this could be, if you're on Linux, your home directory. On Windows, it's Documents and then the version of Houdini that you're running. And look for this toolbar directory. If the toolbar directory isn't there, you can just create it. Then going inside, paste these two shelf tools, FK Controls 3, it might be just called FK Control, and Lock All. So having pasted those in, we'll start Houdini up again, and then we'll add these to our shelf. So if we click our rigging tools shelf, we can see that currently it's empty. But now we can right-click in an empty space here and say Edit Shelf Tab. So this brings up our Edit Shelf tool again with our options. But now if we go over to Tools, this lists all of the tools that are offered in Houdini. So you can add any of these that you want to this shelf. The ones we want are the ones that we added just a moment ago. FK Control, Lock All. So you can just select each of those two and then hit Apply and Accept. And now you can see that FK Control and Lock All have been added to this rigging tools shelf. So we're going to start with Lock All. I'm just going to place a null here in the network. If you'll remember from when we were building our spine, some of these parameters we were promoting, and so they were getting a channel reference. Here I'm just keying to represent that. And then we were manually locking each of these, and that was kind of time consuming. And in a rig you could have hundreds of nulls and hundreds of bones. So doing that over and over again is really laborious. So if we look at this Lock All script and we can right click on the tool and say Edit Tool, you can see that its name is Lock All and the label is Lock All. And then if we go into the script, you can see it's fairly simple. It's just doing a little loop. So all of the shelf tools know about whether you control click on them or shift click on them, and then there's a number of things that you can do there. So I usually just add this little boilerplate here automatically. But the meat of the tool is here. So we get the selected node. So when we select a node, that will be put into this nodes variable. And then we have a series of parameters here listed as translate, rotate, scale, pivot, translate, pivot, rotate, and scale. So that's these guys here. And what we want to do is we want to lock them, but only if they don't have a keyframe or an expression. So in this case, we have some keyframes on our rotate. So we don't want to lock these, but we do want to lock everything else. And you can see here I'm using control click. So if the user has control clicked on this lock all, it's going to lock 0, which means unlock. Otherwise, it's just going to lock. You can see I've selected the node, and then I come up here to lock all. You can see all of these have been locked, but the rotate parameter has been left alone. And if I wanted to undo that, I could then simply select again, and then with Control held down, click Lock All, and it will unlock everything. And again, it'll leave the rotate alone. So that'll be super useful for us throughout the rest of this series. Boom. Very fast. The next script that we're going to look at is this FK Control. And it's doing a lot more stuff, but it's all pretty simple. Essentially what it's doing is it's getting a selected node and just using that so that it can know where in Houdini it is. And then with this UI read input, it's going to put a little pop-up and it's going to ask us for a prefix. So we supply that prefix, and then it's going to use that prefix to create the names of the nodes that we're going to create. And we're going to create an offset node, an auto node, and a control node. And you'll see what those are doing when we're done. And then each of these sections is just the Python script to create those nodes. And then if we use control click, it's going to go and lock a bunch of those parameters. So that's sort of an option. So if we try this out, so we've selected a node, and now we hit FK Control. It gives us a little pop-up. So it's asking us for a prefix, so we can just say test. When we hit OK, now we get 3 new nodes with test, which was the prefix that we supplied. So we have a null that's test offset, a null test auto, and a null test control. And you'll notice that offset and auto are not selectable and they're not displayed. And also if you go inside, they're empty. Because we're not going to be using these interactively in the viewport, it's not necessary to have the control object and the point stop there. The test control, however, is something that we'll be using in the viewport, something that we can manipulate our rig with. So it's selectable and it's displayed. It's got a slightly different color, and then inside it's just a regular null. So you can use this script to create lots of things like this. And just by editing the tool and playing around with it, you can create different nulls. You can set their display, like in this case, the control type of our test control node has been set to circles on the XY plane. And that's orientation set 3 is for XY plane. But you can play around with this, and you can make new versions of this to do all kinds of other things. So we'll be using these quite a lot throughout this series, and they'll really save us a lot of time. So our spine is finished. In the next tutorial, we'll be doing the head and the neck. Thank you.